Okay, good morning, dear students. Hope I'm audible.
Yes, sir. Good
Okay,
morning.
yeah, and I hope all of you can see my screen also. Is the screen shared? All of you can see.
Yes, sir.
Okay, okay. So previous class, so you people understood dynamic memory allocation, how the memory gets allocated dynamically, uh, difference between malloc and calloc, and when to use the reuse. In case when you have allocated some amount of memory dynamically, say I computed it as 20 bytes of memory is required, and I allocate 20 bytes of memory either by using malloc or calloc, and that difference, the difference between malloc and calloc, how the memory gets allocated. And if I feel like that memory is not sufficient, so then I can go for again calling reallocate, and either go for increasing or decreasing the memory that is allocated. So this is what can be done using realloc. And one more important thing in realloc is that sometimes what happens, so the same memory that is allocated, okay, gets extended, simple extension of the memory, and that completely depends on the operating system, that you cannot predict. So if it's not possible to extend the same memory that was allocated earlier, so then the operating system will completely go for allocating a new block of memory, completely new block of memory, if it's not possible to extend the previous memory. Now that case, what realloc will do is all the values, previous values which were there in the previous memory block, which could not be extended now, so the values gets copied to the new memory block that is going to be allocated. Okay, so that is what the realloc function is. And even the third program I executed it, the one example on the realloc, and I showed you how the addresses are going to change. But unfortunately, when I executed, I think I executed that program for two times or three times, and on each time I got a different memory block allocated. So and we were not able to see the same memory block getting extended with additional addresses. So and that happens randomly, and that is what I told, it is completely dependent on the operating system. So that is not in our hand. Okay, next, these are a few things what we understood in the previous class. uh, Now today we'll understand string processing, and you already completed one lab program which was completely based on the array operations. So now the next topic is string processing, and you have one more lab program on this which is based on the string concept. So before that, it is necessary for us to understand the entire string processing concepts, and then we can go for having the lab program. Now we'll try to understand the basic terminologies that are used in the string processing. So you take any programming language, it contains a character set that is used in order to communicate with the computer. So basically, as a user, you'll be communicating with the computer system using the character sets that are available. And this is true for any programming language. Even if you want to send some command to the computer, it is through the character set. You got to key in some character set, and the computer understands that character set and responds to you accordingly. So any programming language has its own character set, and that is used to communicate with the computer. So the set example, what are those character set? So alphabets, So from A to Z, something like this, and even you can also write lowercase letters also, A to Z, digits from 0 to 9, some special characters like this, plus, minus, slash, into, open bracket, comma, dot, dollar, equal to, single quotation. So double quotation also, of course, you can write. And the square box what you're seeing here is the symbol that is used to represent a white space, because white space I cannot write and show you. Even if I give some space, I'm giving a space there, and I cannot tell there is a space. For our convention, we are using this symbol in order to represent, sorry, this small square what you are seeing here is used to represent the white space. Okay, so now from now on, whenever I say one white space, so you got to write it as one square. And if I say you two white spaces, so you got to write two such characters. And this is the convention which we are using in order to mean the blank space or the white space. Okay, the set of special characters. Okay, so these are all the special characters, which includes the blank space as well. The last one what you're seeing is the blank space. So don't get confused, sir, do we have this character also in the character set? So this is the character set, not a doubt, no doubt. But what character is this? It is representing the white space. So frequently denoted by this, we denote it with this symbol. Okay, next, what is a string? And you understood a character. Now each one of this is called as a character. This is one character, and this is another character, and this is one more character, and this is one more character. Now how many such characters you have? So you have around 256 characters like this. Okay, and we have listed only few of them here. So like this, there are 256 characters. How do you say it is 256 character? Because what ASCII ANSI uses. So I hope all of you may be knowing what is ANSI is. ANSI stands for American National Standards Institute. Now, and that ANSI so has given a code for every character. So that is called as Ascii Code. Okay, and what is the size of an Ascii code? It is 8 bits, or nothing but a byte. Okay, and to represent this A in the computer system, so there is an unique 8-bit sequence, and that represents A. And similarly, there is one more unique 8-bit sequence for B to represent B, and there is one more unique 8-bit sequence for representing C, and even there is one more unique 8-bit sequence for representing lowercase a, lowercase b, lowercase c, like this. So there are around 256 characters. Now why I say 256 character? Because to represent each character, so it is using how many bits? 8 bits. 8 bits it is using, or a byte it is using. So 2 raised to 8 minus 1, so that is 250, 0 to 255. Okay, so many 0 to 255 is nothing but 256 character sets. 256 characters are available, and using this 256 characters, you can go for giving the commands to the computer system and have it doing your work. Okay, hope you people are following. So, and we have not listed all the 256 characters here. What we have done is we have listed few of them. Okay, is that clear? Am I audible?
Yes, sir. Yes.
Hello, please respond.
Yes, sir.
Okay. Now a finite sequence yes of 0 or more characters is called as a string. So you understood this is each one of this is a character. Now the finite sequence, okay, the finite sequence of these characters or a group of these characters, you call it as a string. Say for example, you'll write your name. So your name is a group of all these characters, all these characters, either uppercase characters or lowercase characters, along with the white spaces you'll be writing. So you're going to separate your first name from middle name, and the middle name from the last name by using these spaces. Now that is what is a string. String is a finite sequence of 0 or more characters. We say 0 also. Why? Because a string with 0 characters is called as a null string. Okay, or you can also call it as simply empty string. Okay, and the number of characters in the string is called its length. So every string will have, since we are saying it is a finite sequence of sequence yes. Okay, string is normally denoted by yes. We use the notation yes to mean a string or represent a string, and the number of characters in the string, it's called its length. Every string will have its length. Okay, so and the length can be 0 also. And if I say a string of length 0, that means it is an empty string or a null string. That is what is written here in the next point. The string with 0 characters is called as an empty string, or you can also call not, it is not off, or null string. Okay, so you can either call it as an empty string, or else you can also call it as a null string. Okay, next, in case you want to denote a specific string, so then you can do that by using single quotation, or sometimes we also go for using the double quotation, and even this quotation mark, so they also serve as the string delimiter. Say for example, I have the example here, the hint to be or not to be. Okay, and then I think you understood this is one more thing. And what the string consists of, it consists of 2 white spaces, and each one of this this, if I want to consider them as different strings, so then I got to enclose them using the single quotation marks on few systems. And few systems they'll ask, a few programming languages, they'll ask you to specify the strings within the double quotation mark. Now but what I have shown here is the single quotation mark. Now this is one string, and this is another string, and I have one more string here, that is 2 spaces itself is considered as one more string. Now what if I don't include, say for example, if I'm removing this single quote here, and removing this single quote here, and removing the single quote here, and removing the single quote here. Now if I just remove this, and there is no delimiter to distinguish that each of these is a separate string. Now this entire thing will be taken as one complete string. Now if I want to make each one of this a different string, correct, so then I go to enclose them using the single quotes. So the single quotes acts as the delimiter for the strings. Now what I'm doing, so I'm opening and I'm ending, and here also I'm opening and I'm ending. Now this is not considered as one string right now, since each of the string is delimited by using the single quotation marks. It is taken as 3 different strings. Okay, so normally, so as a string delimiter, we use the single quotations, and the strings are with length. Say for example, this is with length 7. Now how do you say it is a length 7? So you got to count the number of characters here. So 1, 2, T is 2, E is 3, and there is a blank space between these two, white space between these two. Even that is also counted. 4, 5, 6, 7. So length of the first string is 7, and similarly the length of the second string is 18. So you count all the characters here along with the white spaces, it comes to around 18, and the length of the last string is 2. Okay, because there are only 2 white spaces and it is 2. Okay, now so this is I hope you understood what is a string, and what is the length of the string, and what is the delimiter used to represent different strings within the system, and what is a character set, all these things. So next is storing the strings. Now what are the 3 ways of storing a string? There are 3 ways using which you can go for storing a string within the system, or the sequence of characters within the system. One is fixed length structure. This is the first approach. Another one is variable length structure with fixed maximum. I'll tell you what is this. Okay, variable length, but again there is a fixed maximum. And next one is a linked structure. So these are the 3 different approaches, or the techniques that can be used in order to represent a string within the system. So fixed length structure is every thing which you write takes a fixed length. Say for example, I'm writing my name it takes a fixed length. Say for example, the length of a line is 80 characters. So even though I'm writing my name, say Arish, so which is actual length is 6, but what it will do, it will occupy a length of 80 bytes. And what will happen to the remaining 74 bytes? They will be filled with the null characters or the zeros. So that is what is fixed length structure, because if the system says the length of a line is 80 characters, even though I'm writing my name, which is actually 6 characters in length, say Arish, so it is going to occupy 80 characters. Okay, and what is happening to the remaining 74 characters? They're all filled with the null characters or the zeros. Next is variable length structure with fixed maximum. So again we have a fixed maximum. Say for example, the maximum length of a string can be 80 characters, and what I'm entering is and the actual length of the string can be variable. So maximum is fixed, say 80, so that means I cannot enter more than that, and within this 80 the length of the string can be variable. Okay, length of the string can be variable. So for example, so I'm using the second approach, variable length structure with fixed maximum. Now I want to store my name. I just key in Arish, H-A-R-I-S-H. How it gets stored? Only Arish. What happens to the remaining 74 bytes? Nothing is stored there. Okay, they're still blank, and even when I'm reading my name, when I want to read my name, I don't have to go and read those 74 bytes. Okay, so this, and there is the other thing, which is a linked structure. Okay, so in the linked structure you don't have even the maximum fixed maximum is also not there. Correct? No, that means the length of the string can be dynamically changed to any length. So this is we have the concept of, again I'll open the whiteboard and I'll write you and show how the linked structure works. So this is by using the concept of linked list. So we every character is represented as a node. Okay, the node will have two fields. One is the info field, another one is the next field, or else you can also call it as an address field, which holds the address of the next node, which is holding the next character, something like this. This is creating a chain of characters in order to make it as a string of unlimited length. Okay, so these are the three approaches that can be used to store a string within the system. So first is a fixed length structure. I hope you understood what is a fixed length structure is. So if every line is fixed to have in 80 characters, so you just type some string from the keyboard, it will of even lesser than this 80 characters, so the length of the string is taken as what? 80 maximum. So the other approach is variable length structure with fixed maximum. So the fixed maximum, let us assume again 80. So if I'm keying in my name, which is only a combination of 6 characters. Okay, so what it will do, only my name Arish is stored, and after that it uses a convention of double dollars. I'll tell you later in my next slide. So double dollars it will use just to mean that the string is ending here, and it is not necessary to read the characters after this, because the string itself is ending here. And the other one is linked structure. Okay, now I have here the record oriented or the fixed length storage. The first approach is explained here. So that is what I told you, 80 columns or 80 characters. So it fixes. So the even if you entering the string which is less than 80 characters, so it used to consume the 80 characters positions. So actual name and followed by the null characters. So disadvantages, this I've already told you. Disadvantages: time is wasted reading the entire record if most of the storage consists of inessential blank spaces. So this is what I told. So you're wasting the time reading all the 80 characters. Even if, say for example, my name Arish, only 6 characters I got to read, but since this is a fixed length storage, okay, even I should go for reading all the 74 characters which are right now assigned with null character. Okay, and certain records may require more space than available. Yes, so this is also what I told. So Arish I'm entering, but still it will span for what, 80 characters. And one more important disadvantage is that when you're doing corrections, so corrections you want to do it for the fewer characters so than the original text. So changing a misspelled word requires the entire record to be changed. So these are few disadvantages associated with the fixed length storage. Next is variable length storage or fixed mechanism. The storage of the variable length string in memory cells with fixed lengths can be done in two ways. So there are two ways of doing it. I was mentioning double dollar. This is what the double dollar. So we can use a marker such as $2 to signal the end of a string. Say for example, just observe here, I'll write. Say I want to store my name. Arrays I have written. So and after my string ends, I'll be just storing the double dollars. So what this indicates? So this is the string and it is terminating here. Okay, the string gets terminated the moment two consecutive double dollar signs are seen. So it indicates the string is ending here. So it will read only till here, and the characters after this will not be read, meaning that the string, this is the end of the string. So even though it is maximum fixed character is 80, like this one line you can store how many characters? 80 characters, like this. I'm just entering my Arish, my name Arish, and after that immediately I'll store two double dollar signs. What this indicates? The string terminates here. Okay. In case if I want to add one more, so Arish Kumar, and after that two double dollar signs. That means the characters that are seen after this two double dollar sign will not be processed. Okay, so you have all those disadvantages which we understood in the previous approach, that is fixed length approach, are solved here. So just by having the concept of terminating the string by using two double dollar sign. So one can list the string, one can list the length of the string as an additional item in the pointer array. So or in other words, what you can do is the second approach. So I don't want to use the double dollars. So then at the beginning, so before writing, say for example 06, and then I write Arish. Now what does this mean? So this the beginning is holding what? The length of the string. Okay, the 06 is saying the string which I'm typing is of length 6 characters. So it will read from here to 6th character, and the characters whatever after there will not be read or will not be processed. So this is the second approach. In case if I don't like to terminate the string by using the double dollars, then I can go for adding the length of the string as a header even before the string, and this gives an additional information and tells even before I go for reading the string that this string is of length how many? 6 characters. So and I'll be reading only the 6 characters. So that's it. Hope you people understood. Hello.
Yes.
Hello.
Yes, sir.
Yeah. And the third approach is the linked structure, and this is what the approach that is used by the majority of the systems as of now for storing the what strings. Now how this happens? So let me write something and explain you. So I need to take few diagrams for this purpose. So insert shapes, let me take. Okay. Yeah, now so each one has two fields. I think the color I have to change. One, two, three, four. Let me write my name. Okay, now I'll just copy this. One more. One more. Here each one, this one is called as a node. Okay, and this has two fields again. This is one field and this is another field. Each node has got two fields. So this I call it as, okay, info field. This field is called as info field, and this field is called as the address field. Okay, now let me add some text to this. Okay, say I want to store my name. I store H here. Okay, and then here I store A, and store R. Here I store I. Here I store yes, and here I'll store H. Okay, now so this is the info field of this particular node is containing H. This is the info field, and this is the address field. And info field of this particular node is containing my second character of the name A, and then R, I, S, H. Next, now what this field will hold? This field here. So let me just go down. Say address of this node, okay, is 1000, and address of this node okay is 1200. So I'll take some random addresses, let us not worry. And this particular node, say 1300, and this particular node is 1400, and say this node address is 1200. Showing all these things is a little difficult here, but I'll try to manage. So address of this is 1400, and yeah, this I think I extended. Okay, so address of this, okay, let me write here 1500. Address of this is 1500. Now what happens, this node here, add text, it stores 1000. Okay, that means, so this is storing, the info field is storing the first character, and the address field here in the first node is storing the address of the next node. That means there is a pointer from here to here. From this node I can reach this. So what it is storing is address of this particular node. Since this node knows the address of the next node, so it knows how to reach this node from here. Okay, I'll just add a pointer, something like this. Okay, and what will be stored here, can you tell? 1200.
So 1200.
Yes, I'll just show you. So it is 1200. 1200. Okay, that means, so from this node you can reach this. So this is what is a linked structure. Okay, and finally, so you'll be having address of this node 1000 or 1300 stored here, and 1400 stored here, and this 1500 stored here, and this is my string is ending here. So this will not be holding address of any node. So this will be storing the null character. Now how do I write normally null characters as written like this? So I just the color is not visible. Okay. So something like this. We just say this is the null character. And here again pointer to here, pointer to here, pointer to here. So I hope you people understood. This is what is the linked structure storage of the string, and this is the most widely used one. Okay. Let me save because I don't want to lose this. Let it be as it is. Okay. We'll go to the next one. Okay. Next slide. I hope you understood all the three ways of doing it. Okay. Next. Okay, so character data types, you know that. So every programming language has a data type for storing a character, that is character data type. The constants, many programming language denote string constant by placing the string either in a single quote or double quotation marks. This you already know. Variables, okay, each variable, each programming language has its own rules for forming a character variables. So however, such rules fall in one of the three categories. So three categories. First thing is static. By static, a character variable, we mean a variable whose length is defined before the program is executed and cannot be changed throughout the program. So that is what is a static character variable. That means once you define the length of the character, it is fixed and it cannot be changed during the program execution throughout the program. So you cannot do that. And semi-static, we mean a variable whose length may vary during the execution of the program as long as the length does not exceed the maximum value. So this is something similar to your the first approach, fixed length. Okay, I'll just show you fixed length approach, which we understood, fixed length structure. Okay, static is something similar to this fixed length structure, and semi static is variable length structure with fixed maximum. Okay, so and then dynamic, fully dynamic one is a dynamic character variable. We mean a variable whose length can change during the execution of the program. Okay, that is what is the linked structure. So as and when you want to increase the length of the string, you can go for adding more number of nodes and just make the nodes hold the address of the next node. Okay, a chain is created. Next, string operations. So till now you understood how the character is represented, how the strings are represented in the system. So now it's time to understand the string operations. Okay, so although the strings may be viewed as a simple sequence of linear array of characters, so there are fundamental differences. So even though when we are weaving the string, when we go for weaving it as an array of characters, but there are fundamental differences between the string and other types of arrays. So when you can take a string array and the integer, normal integer array, there are basic differences. Okay, specifically A group of consecutive elements in a string called substring may be an unit of themselves. Okay, and this is not possible. You cannot have something called as the substring concepts in other type of arrays, and you can have the concept of substrings only within the string arrays. Okay, so as an example, we'll see this to be or not to be. Okay, so this is a string, main string, which has many substrings in it. So TO is one substring, B is another substring, OR is another substring, and if I consider this OR and NOT itself is one more substring. Okay, so if I take this OR and NOT as one substring, and within this substring there are again two substrings, OR and NOT, something like this. In this manner, the string arrays are little different from what the normal integer arrays or the floating point arrays. And in any point of time, if you want to access a substring from the given string, it requires three pieces of information. Say for example, this is the given main string, and from this string I need to access a substring. Okay, now what are the three information that is required for me to access a substring from the given main string? First thing is the name of the string or the string itself. Okay, so before you access any substring from a given string, the first thing that is required is the string itself is required. The main string is required. If the main string is not available, then it is not possible for you to access any of the substring. So second thing that is required is the position of the first character of the substring in the given string. Okay, first the main string is required. Now once you have the main string, next thing that is required for you to access the substring from that main string is the position of the substring. From where, from at what actual position your substring is starting. So that is required. And once you got the position of the first character of your substring, so what else is required? So you require the length of the substring. Okay, or the position of the last character in the substring. So either you require the length of the substring or the position of the last character of the substring. So when you get this, all these three information, so then you can go for easily extracting the substring from the given main string. Hope you understood till here.
Yes, sir.
Okay. And now the one which I mentioned you right now, the three pieces of information that is necessary for accessing a substring from any given main string, so can be programmatically represented something like this. Substring, so this is the name given to some function. What it will do, it will extract the substring from the given main string. Now what are the three pieces of information I'm sending? So first thing is the string itself. This is nothing but your main string, and second is the position where the first character of the substring is starting, initial, okay, or the starting, okay. And then the third piece of information that we need to pass in order to find the substring in any given main string is the length. So this is how we will be writing a function for finding the substring within a main string, and these are the three pieces of information that is essential for finding the substring within the main string. One is the string itself, the main string, and then the position of the first character in the substring within the main string, and then the length of the substring. Okay, length of the substring, or it can also be sometimes the position of the last character in the substring. Okay, we have example here. Okay, substring. Now what is my main string now? See, string, I've taken this to be or not be. Okay, this is my main string. So, and this 4 is saying the initial or the position of the first character of my substring. So 1, 2, 3, 4. Okay, from 4 the initial, now to a length of how much? 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, this is what is fetched, B or not N. Okay, so this is the substring which I was looking for in my main string. This is B or N. Okay, so I got it. And similarly I have another example, substring. So I have taken this main string as the end now, 4 and 4 I am writing. Okay, so I'm just trying to take the substring from this string which is starting from the position 4 and is of length and it is up to length how much? 4. So 1 2 3 4. So it is starting from the white space, okay, and going up to 4 characters again from here. 1 2 3 4. Space, the end, is a substring. So this function, so if I call substring function something like this, so this is what it is going to return me. Okay, people understood? Yes.
Yes,
Hello.
sir.
Yeah. We'll go to the next one. So now in the previous slide here, you understood how to extract a substring from the given main string using these 3 pieces of information. One is the string itself, the main string itself. Another one is the first character of the position of the first character of the substring, and the length of the substring, or the position of the last character in the last character of the substring. These are the 3 pieces of information that is required. So what you understand next is indexing. Say, so I want to know the position of a particular pattern in my main string. Then I'll be calling a function something like index. Okay, so indexing, also called pattern matching. Okay, so the another name to this is what? Pattern matching, because you're not going to extract the string here, the substring, from the main string. Instead, we are just only interested in knowing whether a particular pattern, okay, exists in my string or not. If it is existing, if the particular pattern is existing within the main string, at what index it is starting. That is what I'm interested in. I'm not interested in taking the entire substring as a part from the main string. So also called as pattern matching, refers to finding the position where a string pattern P first appears in the given text T. So we call this operation index, and we write something like this: index, this is my main string, and this is the pattern what I'm looking in my main string. I have the example here, I'll show you. Okay, if the pattern P, the pattern which I'm looking for in the main string does not appear in the text, so what index will return? So I want this function to return 0. That means it's not found. So if it returns 0, so the pattern which you're looking inside the main string is not found. So the argument text and pattern can be either string constants or the string variables. So now I have the example here. So T is equal to, to this T is a string variable. To this string variable I'm assigning this string. So his father is the professor. Then now I'm calling like this: index T I am passing. You know what is T now? This is the string. His father is the professor, and then this D is the pattern which I'm looking for in my string. Okay, so index T is my original string or the source string, and this is the pattern which I'm looking for. Now this particular pattern, is it present inside this string? Yes, it is there. At what index this is starting? So 7. It is starting with the index 7. So you can just count from here. Yeah, sorry, not this. So even THE, this pattern is found here. So it will return the position of what? The first occurrence of the pattern. Okay, so this is the first occurrence. D is here itself. This is 1 2 3, and this space is 4 5 6 and 7. You have the first occurrence of the pattern THE in the source string starting from the index value what? 7. Hope you people understood. And next I have another example here. So then, sorry, index T, I'm looking for the pattern then. Okay, so this pattern THE and then. So is there a pattern THEN present here? See, I start from here. I find the first character of my pattern T. H is also there, E is also there, but N is not matching. So that this is not the pattern which I'm looking for. Okay, and I continue further searching. This is again THE. After this THE I have a space, but what I'm looking for is N. So it is not there. Now what this index is returning, as I already told, if the pattern is not found, so what it returns? 0. That means the pattern is not found inside the given string. Yeah, so not found. Next, I have another example now. So index t, so this is what the pattern I am looking for now. Space, so space the and one more space after it. Okay, now is this pattern found in my main string? Yes, it is found. See, space the and then space. So this pattern is there. And what is the index of that? And this pattern is starting from what index? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, it is 14. So 14 respectively. So I hope people understood with this how to find the substring within the main string, and what is the logic we use in order to find whether a particular pattern exists within the given substring or not. Hello?
Sir, these operations are predefined or we have to write the code?
No. They are not predefined. This is just the understanding how to go and find out whether a pattern exists or not. And we got to write the definitions for all these things. So they are not there. Getting? Yeah, this is what we are learning now is approaches to do it. That's all. Later, so we are going to use this in our implementation. Getting? So right now,
Yes, sir, yes.
yeah, with this you understood. Sorry. Now with this you understood. With this you understood. When you want to extract a substring from a given string, what is the information that you should have? So you should have information of the source string should be available, and you should know the position of the first character of your substring.
Initial.
Yeah, initial. Yeah, position. Initial is nothing but the position of the first character in the substring, and then you should have the length of the. You should know the length of the substring. Now, if you know all these things, then you can go for writing easily a function with the name substring using all these things and find out extract the substring from the given main string. And similarly, in case if you want to check whether a particular pattern exists in your given string, so this is how you got to do it. Okay, just the steps or the knowledge that you should have in order to find whether a particular pattern exists in the string or not. Later we will be writing a program for all these things. So this is the conceptual understanding. So later we code it. Okay. And the second lab program which I was mentioning on the string is based on all these concepts. So we apply all these concepts there. Next is concatenation. So now you understood, and there are built-in functions available for doing majority of the string operations, but as far as the implementation is concerned, so the lab program, you got to do it without using the built-in functions. So the main idea behind saying don't use the built-in functions is just to make you people understand the concepts of the strings, how it works. So you don't have to use the built-in function. Now if you're able to write your own functions, what does it mean? You have the thorough understanding of the string representation and their working. So if you are directly doing it by using the built-in functions, you may not have the thorough understanding of the string representation and their operations. So just to test that, they made the lab program without using the built-in functions. Next is concatenation. After understanding how to extract the subpart of substring of from a given string, and how to check whether a particular pattern exists within the main string or not, next is concatenation. So concatenation is nothing but joining two strings. That it is in simpler terms, combining two strings. So I have the example here. So I'm considering two strings s1 and s2. Okay, let they be two strings. The concatenation of s1 and s2. Say I want to concatenate these two. Now how it is denoted? Something like this: s1 2 slashes s2. It is nothing but the concatenation of s1 and s2. Now here I have the example. Say suppose the string s1, let us assume it is equal to Arish, and string s2 it is equal to Kumar. So then, so if I write something like this: s1 concatenation s2. So this is a concatenation operation. So Arish, Kumar is appended with Arish. Now if I want to give a space between these two, now this is how I do it. So s1 I am concatenating. So I hope you know this. It's a white space. Now when I'm giving white space, it has to be in a single quote. I'm using it in a single quote, and to this again I'm appending s2. Now I have my name concatenated using this space. Okay, Arish. So this is Arish, and then a space, and then a Kumar, like something like this. Next, and length, this I've already told you. The number of characters in the string is called its length, and we'll write it something like this: length of the string. And there is again a built-in function to find the length of the string, that is strlen. Using that you can go for finding the length of the string at any point of time. And similarly there is a built-in function in order to do even the string concatenation also, strcat. Using strcat you can go for concatenating the two strings. Now what I'm doing here, say s is equal to this, this is the string computer. Then if I say length of s, it should give me the length of number of characters in my string. And similarly length of this, so it is giving me 12. It is including this white space. So length of this string is 12 characters. So if you want, you can do all these things by even using the built-in function strlen, or otherwise if the question says don't use the built-in function strlen, so you can also do this by using by writing your own function. Okay, length, and you can always go for finding how many characters are there. Next is word or text processing. Okay, so earlier times, olden days, character data processed by the computer consisted of small data items such as names and addresses. But these days, so the computers are processing a large amount of data. So such as it may be a printed matter, such as letters, articles, and reports. So there is huge amount of word or text processing happening these days compared to early days. In early days, only small amount of data such as names and address used to get processed. But these days, with the advent of so many things, you can have a printed matter which is in the scanned format. So you even convert that into the text format, and then you go for processing. So this is the place where we feel the string processing is very much essential. So you can call it as string processing, or else you can also call it as the word processing. So given some this printed text, the operation usually associated with word processing are these things. Now what is the word processing? Replacement. So going to replace one string with the another. So for a given string, adding some new string, okay, at the specified position, and from the given string deleting a part of the text. So this is what basically the text processing operation, or word processing operation, or string processing operation, and which we will be doing. Even in the lab program, you'll be doing all these things. And you have done this even in the arrays also, but that was related to integers. So you used to read an integer array, and then you used to replace, and you used to insert, and you used to delete from that array. But the same thing we do now using these strings. And one example for the strings. Okay, suppose say there is a text t given, and I want to insert a string s, okay, so that s begins from the position k. So we denoted something like this. So you understood substring, you understood the index, and then you understood this one, length. So now inserting. So even for inserting, you require the original text, and then you should know the position from where the new text needs to be inserted, and the new text that needs to be inserted. I have the example here. Insert. This is my original string. Say A B C D E F G, and I got to insert this new string XYZ from the position 3. Okay, from the position 3. So now after you write a set of statements in order to do this. So this is what the expected output. AB. So since I'm saying insert XYZ from position 3, 1, 2, 3. From position 3 you have XYZ, and you have the remaining part of the source string appended to XYZ, something like this. So this is an eye level view what we are discussing. Later we discuss how to code this, how to implement this actually. And I have another example here. Insert ABCDF 6 XYZ I have given. Now what it is happening, the same substring XYZ, now it is getting inserted to the original string from the position 6 onwards, XYZ, something like this. And now how to do it? So this insert function can be implemented by using the string operations as follows. So insert T is my original text, K is my position where the new string S needs to be inserted. Now this insert can be something like this now. So first what I'll do, I'll find the substring. See, the insert can be implemented using the substring function. So substring you already know. Substring, main string, from the beginning, okay, till k minus 1. What is this? K is the position where I want to insert my new string. So I'm getting that substring. That is, say for example, this is my main string. Now I want to insert at position 3. So I'm getting this string. AB is the string which I'm extracting. And to that AB, what is that I'm appending? So this is append symbol what I told you now. Okay, this means what? Append. So what is that I'm appending? Appending this XYZ. To AB I'm appending XYZ. And to that what I'm appending? A substring of my main string, which is starting from the position K and which is up to a length of this. See, I'm finding the length something like this now. Length of T minus K plus 1. So why I'm doing minus K? Because it is a substring right now. Okay, AB, to AB I'll append XYZ, and to this AB XYZ what I'm appending is C, D, E, F, G. What is the length of this? 1, 2, 3, 4, 5. How to find this? By using this length of total length of your original string minus K, which is nothing but the position from where you go to insert the new string, plus 1. Okay, this gives you the length of the another string. Okay, take that and you append. Okay, people understood till here?
Yes, sir.
Yeah, this is what the conceptual understanding. So if you know all this thing, all this concepts, then the program you can easily understand. So this is all your programs are implemented on this concept. Okay. Hope you understood, wrong? This statement you understood, I think. So now insert can be implemented by using substring concept. Okay, which we have already understood. So next we have similarly delete. Okay, so how do we delete a text or a substring from the given main string? So similarly, how delete is implemented using the substring concept. Okay, now what we'll do now, so we'll stop at this point. Okay, and from the delete, from here we'll discuss in the next class. So I have a few more slides here. Delete is one, that's all. Delete is the last one. So if I complete this, the string operations are complete. So here in the string processing, we are nowhere discussing the built-in function. So it is all the concepts how we do it our own. Okay, So you can write your own function for concatenating two strings, and even you can go for own function for inserting some substring within the main string, even deleting some substring from the given main string. What we do now, we write our own functions, and with all this conceptual understanding, so next we'll be writing our own program, which is the second lab program for doing all these things. Okay, so let me stop at this point for today, and tomorrow we'll continue from here, and if possible we'll get into the second lab program. So I think tomorrow afternoon class is lab tutorial class itself. I think I have to give you the second lab program also. So we'll just discuss the lab program, if not fully. So I think it's not possible. Completing this delete and completing the entire lab program is not possible tomorrow itself. So at least let me give a start tomorrow for the second lab program. Okay, and I hope all of you, those who have finished the lab batches till yesterday, have completed executing the first lab program, and you have understood it. And whoever has the lab today, tomorrow, and day after tomorrow, please execute the first lab program first, and later continue with your sample programs. So if you have any queries on this topic, string processing, please do ask me now. I'm downloading the attendance list. Yeah, it is downloaded. Yeah, if you have any queries, please do ask me before I stop. So no queries?
No, sir.
Okay, then all of you can leave and join your next class. Okay, thank you.